Section 3.5 is called Position of Equilibrium and Choice of Reagents. And in this section, we're going to be reviewing what you've already learned in Gen Chem about determining whether the position of equilibrium lies on the left side or the right side for a reaction. And we're also going to be learning how to take that concept and apply it to a lab situation where you would be choosing different reagents to produce a desired product. So first of all, let's consider a generic reaction, HA plus B minus in equilibrium with HB plus A minus. If we wanted to determine whether the position of equilibrium lied on the left side or the right side for this particular reaction, we would compare the relative stability of the two bases in this reaction. In this particular reaction, the two bases are B minus and A minus, and we would use the REO techniques from section 3.4 to figure out which of the two bases was most stable, or we would use pKa values if the REO techniques didn't work. In general, the reaction is going to move towards the most stable base. So if we found that A minus was more stable than B minus, that would mean that the position of equilibrium lied on the right side. The reaction moved toward the most stable base. This sounds different from the way it was taught to you in Gen Chem, but it's not different. In Gen Chem, you learned that the position of equilibrium was determined by the strength of the acids. And you learned that the position of equilibrium moved away from the strong acid. So let's say that HA and HB are the two acids. Let's say that HA is the stronger acid. In Gen Chem, you learned that that would mean that the reaction would move away from the strong acid. In Gen Chem, you also learned that strong acids produce weak conjugate bases. And we've learned that stability of a base comes from it being a weak base. So weak bases are the bases that are the most stable, and this means that we're saying the same thing as what you learned in Gen Chem. We're just looking at it from a slightly different angle, one that's easier for us to analyze using the REO techniques. So let's apply this to an actual reaction. Let's say we have this molecule, cyclohexanol, with hydroxide ion to produce these two products. And let's say that we were in the lab and we wanted to produce this particular compound here from cyclohexanol. And our question was, would the hydroxide ion be a strong enough base to cause this reaction to lie, position of equilibrium to lie on the right side so that we could actually produce some sufficient quantity of this product? In order to determine if this would work in lab the way we wanted it to, we would compare the relative stability of the two bases, hydroxide ion and this compound over here. Now, in this particular example, this is a tricky one because we can't use the REO techniques here to compare relative stability. They both have their negative charge on the same atom. There's no resonance structures for either one of them. There's no inductive effect because we don't have any halogens or other electronegative atoms. And they're both sp3 orbitals. So it doesn't work for this case. And because of that, the only way we could figure this out is by going to a data table and looking at the pKa values of the two acids and relating that back to the bases. In doing that, which we've learned how to do already, you would find that of these two bases, hydroxide ion is the one that is the most stable. And our other ion is less stable. Now this means, from what we have learned up here, the reaction is going to move towards the most stable base. So this means that our reaction is going to proceed in this direction. The position of equilibrium lies on the left side, not on the right side where we want it. And in a practical sense, that means that the hydroxide ion is not a good choice if what we want to produce is this compound over here. What we would want to do then is go back to our other choices and find a base that is less stable than our desired product, so that this would become, relatively speaking, the most stable product. That would cause the reaction to move the way we wanted it. So this is just taking the concepts that you've learned and giving them a context, giving them a purpose. In order to practice this, you've got two skill builders, 310 and 311. And problems 29, 30, 49, 52, 31, 32, 40, and 42. And your study question is, how do you predict the relative stability how do you predict the position of equilibrium? For an acid-base reaction. The next three sections in your textbook, 3.6, 3.7, and 3.8, they're all interesting. I would encourage you to skim through them. A lot of them are going to become relevant next quarter when we start working in the lab. They're lab-based concepts. They're not really things that we teach in the lecture. So skim through them, just get kind of a general idea for it. Don't do any of the problems that are related with those sections, and know that you're not going to be tested on any of the content in 3.6, 3.7, 3.8. Just have a look at it. Familiarize yourself with it, and be ready to learn about that in the winter and the spring quarters.